Okay, everybody. This is. I don't have my pen. Do I have my pen? No. Okay, I will find my pen later. This is object-oriented programming or programming, CSE 241 for the undergraduate students and 501 for the graduate scientific prep students. How many graduate students do we have in the classroom now? 1, 2, 3, 4, 5. Okay, I have the attendance sheet. It looks like I have 28. So I only have no. Sorry. I have 16. So 5 out of 16 is not bad. Yeah. For some reason, the number of students that I have in my list is very small. Okay. I think the registration process is not complete yet. That's why today you are going to write your names and sign your name. Okay. So don't look at the list yet. Just write your name and sign it. Let me begin with 241 541. Today is 9:26. So let's start with I don't know what's going on with the projection device. It's acting up. I think it will be okay. Okay, so today I'm going to go over the overview of the course, what we are going to do, the rules for the course, and then we will start our course. We will start lecturing about the object-oriented programming. After I discuss the syllabus, which is available on our Teams page. By the way, I set up a Teams page. Let me show you. Everybody is using Teams, I suppose, and this is our Teams base page. It is 222 Fall GTU BM CSE 241501. And for now, I think I have a few things. One of them is the PowerPoints of the book slides. It's a zip file. The other one is, I guess, the syllabus. Yes, the syllabus, the very syllabus that I am discussing right now. Just two things. The Teams page is very important, so I am expecting everybody to sign up to this page, because we will be doing our announcements and the homework submissions and etc. in our Teams page. I am sure our undergraduate students have used the Teams page before. For the other courses, for the new graduate students, maybe some of you did not use it. It is a simple thing. Just install it and log on with your GTU email and password, and look for this name. Okay. Can I make this bigger a little bit? How am I going to make this bigger? Maybe I should do this. And like that. Did I get anything? No? Do it again. Is it here? Yeah. So maybe I should just so make this a little bit bigger so that you can see it. So this is the name. Okay, just make a note, just type CSE 241, 501, 241 and 501, you will find it. Okay, so this syllabus is available in our Teams page. So let's go over the syllabus. My name is Yusuf Sinan Akgül, and this is my email address, and this is my phone number extension in our university. And these are our three teaching assistants, TAs, İlhan Hoca, Şeydanur Hoca, and Niyazi Hoja. They will be helping us throughout the semester this year. I think Ilhan will be the lead TA. We are not sure. We didn't make that decision yet. That doesn't matter who is the lead TA. All the instructions for your homework submissions and etc. will come from the Teams page, not from the specific assistants. Okay. And as I said before, we will be using our Teams pages for everything about announcements, course information, homework announcements, class cancellations, and postponement and etc. We will not use Moodle. Okay, we will not use Moodle. We used to use Moodle maybe 2 years ago. Maybe some of you remembers it. We are not going to use Moodle at all. It will be all Teams. The required textbook is this, Absolute C++. It is the 6th edition. Okay. I think our library over there, it has a few copies of 5th edition. Okay. And if you somehow have the 5th edition, you don't have to buy the 6th edition. But 6th edition is better because it has some updated stuff, especially about C++ 11. And the slides and the source code and some other course material about the book, they are all available at this web address, Pearson Higher Education site, at this Savage name. Savage is the name of the writer of the book, one of the writers of the book. He's a very famous computer scientist, and he has this book. The book is not that, the book is good. We like it. Sometimes it is not enough. If it is not enough, then I will bring some material from some other sources, some other web sources, or some other books. Okay. And this is the cover of the book, but it changes from copy to copy. 6th edition, and Amazon has this, amazon.com.tr has this for 500 Turkish liras, as I checked yesterday. So I suggest you buy it, or at least you buy a used copy from last year's students. It's a nicely written book. It is easy to read. Don't try to pass this course using the slides or the PDF and that kind of other sources. Buy the book and use it. At least borrow it from somebody else. I know 500 Turkish liras is not cheap, I know, but I mean that's at least it is not 500 Turkish lira, 1,500 Turkish liras. Okay, it is less than 1,000 liras, but I mean it is what it is. I think if you try to copy it, how much would it cost to copy a book of size maybe 600 pages? Does anybody know? If you try to copy 600 pages, how much would it cost? 200 liras? How much? Really? Yeah. So it is not any more expensive than the straightforward copy of it, and it's in color. Okay, so again, these slides are available in our Teams page, and you can copy paste this title to your search. For the course, as you know, this is the continuation of our programming course that you took last semester, CSE 102 C programming. The name of this course is not C++ programming. This is object-oriented programming, okay? The main purpose of this course is not to teach C++ programming to you. It is to teach object-oriented programming to you. But we will be using C++ as our main object-oriented programming language. And that's why you need to know the C programming language very well. Okay? So for that, um, you need to have a passing grade from this course, CSE 102. It is required. In fact, it's an official requirement. You should have a passing grade from this course, CSE 102. Otherwise, you cannot take this course. For some reason, because of some mistake or because of some error in the systems part, if you are taking this course without a passing grade from CSE 102, okay, it doesn't matter how far you are in the course, your course will be dropped, even if you get an AA from this course. Later, when the system realizes it, they run system checks from time to time. It happens. So if you are in this situation, just let me know. You should have a passing grade from this CSE 102. I know for the graduate students, okay, many of you did not know the C programming language, so this requirement is not valid for you because you are not an undergrad student. You didn't take this course, but you are supposed to know the C programming language from your undergraduate studies. If you don't know it, just learn it, okay? That's going to be a very tough job, I know, because at this department, our C course is a very, very detailed and it's a true course. We start from the beginning of the C and we try to teach almost everything, okay? And I assume that you know everything about C, okay? From time to time, maybe I will go back and I will try to review some stuff in C, but I am not going to teach any C to you, okay? It will be about only reviewing purposes. Some other good books. Well, there are many books about C++ programming language. One of them is the classical one from the Bijan Strostrup. He is the inventor of this language. Okay, he designed it in 1980s, and he wrote a number of books on it. And the third edition is this one. I think Amazon is selling this one too. And I am not saying that this is a required book, but it's a good. Our book is not a good library book. Okay, it's not for reference. It is for textbook. It is for learning the language. But this book is a library book, okay? It is classical, it is for reference. You don't learn the C++ language from this book, but it's a good book to come back and try to remember stuff and try to understand the details of the language and etc. So I am not saying that this book is required, but for any computer engineer, I think you should have a copy of it. At least one version of it. The first version, second version, third version. Doesn't matter, okay? So this is the other suggestion. Good. For the compiler, we are going to use the G++ compiler and Java Standard Edition compilers on Linux, okay? This course will be on Linux only. Whatever you do, you are going to write it on Unix and compile it on Unix. Okay, and you are going to submit your homeworks after that. We are going to compile your homeworks on our Linux machines, okay? And if your homework compiles on your machine and not on our machine, it's your problem. We don't care. And sometimes it changes from system to system, okay? Sometimes in one configuration of Unix, it compiles, but on our machine it doesn't compile, and etc. For that, we will provide you with a virtual machine. Okay. Okay, it is a virtual machine. Any question?
Even we use G++ compiler on Linux.
Yeah. Because I mean, For the G++ compiler, there are some switches. Those switches sometimes defaults change, okay, from system to system. So we don't want to run in that situation, okay. So we are going to give you a virtual machine. You are going to download that virtual machine, and you are going to compile and run your program on that virtual machine and submit it afterwards. And we will test your program on that virtual machine. Okay? We don't care, of course, we don't care where you develop your code, where you implement your code, where you do your testing. But as I said, we are going to test your homework on this virtual machine. Okay? So Linux is our official operating system for this course. Okay? We don't like Windows. We don't like other Apple operating system or whatever. When I say don't like, I don't mean like. It causes some problems. Of course, in our professional life, whatever needs to be used, we use them, okay? But for this course, we are going to use Linux. Okay, when it comes to grading, we will do this approximately, okay? Midterm will be 30%, final will be 40%, homeworks will be 30%, okay? We may change these percentages a little bit, maybe 25 to 35 to 35, etc. I don't know. It depends on the difficulties of the homeworks and the final and the midterm or your grades, but it will be approximately like this. So this is how we are going to calculate your final grade, but there are some additional rules, okay? When we say homeworks are 30%, that doesn't mean that if you didn't do your homeworks and if you scored 100 in your midterm and final, you are going to get 70. Now, that's not the case because we expect you to submit more than 70% of the homeworks, okay? If I assign you 10 homeworks, you are going to submit 7 of them, okay? If you skip submitting those, okay, you will get a grade of NA from this class, okay? NA is a very bad grade. It is worse than FF, okay? If you don't know what it means, just read your student rules of the university. And the homeworks are, as I said before, will be submitted through the Teams page. And on Teams page, we set a due date. If you miss that due date, you miss the due date of the homework. But that doesn't mean that you cannot submit your homework anymore. It means that for each day late, we will deduct, okay, 10% of the maximum grade. So if you are 1 day late, your homework will be graded out of 90. If you are 2 days late, then it will be 80 and etc. After 4 days, we will not accept any homeworks. Okay, it will be enforced by the Teams pages. I will set up those dates when I assign the homeworks, and after that, there is no homework submission. We will not accept any homework submissions through email. You cannot say my Teams doesn't work and I am sending this email to you, etc. If there is a problem with the Teams system, then we will take that into account for the last minute. But if the Teams system is working, then all the rules are there. Of course, this is a large class. There are more than 100 people taking it. And everybody, as human beings, sometimes we run into problems, personal problems, health problems, family problems, and etc. If you are into such a problem and if you won't be able to submit your homework on time, just let me know before the due date and we will try to figure out something for you, okay? So family emergencies, personal emergencies, and etc. we are going to consider them, okay? Your birth date, your best friend's wedding, etc. These are not emergencies, okay? Don't come to me as my best friend is going Europe and I am going to go visit him and etc. Well, do that, but submit your homework first. Okay, good. These are the grading and homework rules. Our midterm exam will be tentatively on November 7th. Okay, that is exactly the mid term. Okay, that's the 7th week of the semester. Semester is 14 weeks of classes, and 7th week is this. On 6th week, we will make our final decision. I will ask you, should we do the homework on that day? And we are going to make the decision altogether. Sometimes that week is too crowded, too busy for you. Some other courses and etc. We will consider it, okay? So tentatively November 7th, but on the November 1st maybe, okay? We will make the decision, exact decision. Final exam, I don't know yet, but usually I do my final exams on the 2nd week of the final exam period. Okay? Any questions? Where is my attendance sheet? Attendance? Okay. Good. And while we are talking about attendance, can you read those slides from back there? Can you guys read it? Okay. For some reason it is kind of small for me, but well, if you can read it, maybe make it a little bit larger. Okay. Attendance is required, and I will take the attendance. Attendance is something serious, and you are responsible from all the subjects covered in the class. Whatever I say, whatever I write on the slides, whatever I say during the lectures, you are responsible. You don't get to say, this is not in the book, I don't have to know this. No, you have to know whatever I'll tell you. That's why you need to attend the classes. And if you miss more than 30% of the classes, then you will get an NA from this course. Okay, these are the student regulations. Okay, regulations of the university. You need to attend 70%, at least 70% of the course. Of course, I am expecting you to attend all of the lectures. Okay, all of the lectures. From time to time, it happens that when it comes to attendance, some cheating has occurred before. We don't like it. I am going to check the attendance sheet from time to time, and if I find a signature whose owner is not in the classroom, that person is going to get, and I think I give them VF something. There is a grade. It is different from NA. It is VF. Well, it's a bad grade. Okay, directly that person is going to get a VF grade if I see something happening. Okay, so if your signature is on the signature page, then you need to be in the classroom. Okay, these are the rules for the attendance. I'm sure you are going to ask the same question again. I got an FF from this course in the previous semester. Do I have to attend, and etc. Everybody has to attend, okay? But the university rule says that if you get an FF from a course before, then officially you don't have to attend, which is a stupid rule. I don't know why they have such rule. I mean, what is the difference between a new student and a failing student? I don't know, but that's the rule. So I cannot enforce it. But if you are a new student, if you are taking this course the first time, or if you did not get an FF previously from this course, at least an FF, then you need to attend at least 70% of the course. I will try to take a recording of this course via using this OBS. OBS is running somewhere. Yeah, see, this one is running, and it is taking this recording, and I will post this on my YouTube channel. Okay, and I try to do this all the time, but from time to time For some reason, technical reasons, sometimes I forget. Okay, I cannot take the recording. So don't take it granted that I will make this recording and it will be available on YouTube all the time. Again, this is about attendance. You need to attend. You have to attend. Okay? These recordings are not for non-attenders. These recordings are for people who attended, but you need to sometimes review whatever I told you in the classroom. Okay? They are kind of helpers. They are not the main things to follow this course. Okay? Any questions? So nobody has asked any questions. Who wants to be the first person to ask it? Oh, you asked a question actually. Who wants to be a second person to ask a question? Okay, good.
If on O2, the lowest two grades of homeworks wasn't counting,
Say it louder again.
the lowest two grades of homeworks wasn't counting.
Well, for the homework, whatever you submit, if it contains anything gradable, we will grade it and we will count it as an homework. Okay. But if you submit something junk, you just submitted your previous homework just to make it count as an homework. No, we will not count it. We will count it as non-submitted. Okay, so it is. You may, I mean, you work hard. You did your homework. Your homework compiles, but it doesn't do the exact things that you wanted to do. That's okay. You submit it and we will grade it. Even if it's a very low grade, let's say 10, 15, 20, we will count it as an homework and we will count as submitted. Okay? But if it doesn't contain anything meaningful, then that's not a homework submission. Okay? We will say that you did not submit your homework. Okay? Usually we have rules about, in order to be able to attend the final exam, you need to take at least maybe 20 from your midterm or the this grade from your homeworks and etc. I don't do that in this course. Maybe I should, but I don't do that. Okay, so it's a possibility that you take a very good grade from your final, and you pass from this course. It can happen, but usually this course is this. I mean, I talk to the people who passed this course before. Okay, don't talk to the people who failed before, because they have failed. Okay, don't take whatever they are telling you. Okay, talk to the people who passed this course before in their first taking. Okay, they will tell you that this course is not difficult unless you do your job on time. Okay, don't try to take the midterm or the final exam by just studying 2 days before. You need to study constantly. Okay, every day when I teach you something new, just go study at home, at lab, at the library, type it up, try to see it is really working, try to get some error messages, try to understand it. Otherwise this course will not go. Okay, this is not like reading a novel. This is not like taking a Turkish class or English class. Okay, by memorizing, by reading the book, you won't be able to understand this programming language, either C++ programming language or the object-oriented programming language. I mean, I am not going to, whatever slide I put up on the screen, okay, it won't be a difficult slide. I won't say this is difficult, just be careful. Everything I will tell you will be very, very simple. It is easy to understand, whatever I tell you, but I will tell you many, many things. Trying to remember all those things, trying to put together all those things takes time, okay? It will not happen in a single night. So if you did not study hard for the whole semester, and for the last 1 week before the finals, if you are trying to learn the whole language, including Java and C++ and object-oriented programming, and try to get a passing grade from this course, no, that will not happen. Okay, that will not happen. But I see that some people struggle very hard. Okay, they say that they studied very hard, but they didn't get a very good grade from the midterm. That doesn't mean that you should just quit or drop this course. You just continue. Sometimes that hard study, hard work pays off in the second half of the semester, and you get a very good grade from your finals exam. Okay. Some people they come late, but they perform very, very good. So don't give up. Do your homeworks all the time, and study continuously. Study on time. Do your homeworks and do more. Okay, do more. I am going to assign maybe 8 homeworks in this course. Some people say that 8 homeworks is too much for a course, because I know some computer engineering departments of some other universities, they say that they don't assign 8 homeworks for the whole department. Okay, they don't do whole 8 homeworks during their 4-year study. Only in this course I am going to assign 8 homeworks, and some of them will take lots of time. I'm saying that even those homeworks are not enough for you to learn the whole language, whole operating system, object-oriented programming. Okay, that's why the rule is, again, talk to the people who passed this course before. The rule is study hard, study on time, and it's going to be okay. It's going to be not that difficult. Okay, good. Homework submissions and announcements. Again, okay, I think I said this before, but just to keep this on record, okay, all the announcements will be made either in the class. I might say that tomorrow there is no lecture, and I don't have to announce this in the Teams page, and that's an announcement. Or sometimes I make this announcement in the Teams page, and the homeworks and the announcements will be at the Teams page. Homeworks will be submitted at the Teams page. Good. Honor code. Whatever you submit as your homework or midterm material or the final material, it should be your own. Do not use someone else's work, including other people's homeworks, or any code from any source. Okay, if you are submitting 2,000 lines of code as your homework, all of those lines should belong to you. Okay, not even a single line of code should come from some other source. Okay, that includes your friends, that includes your family, that includes your any source from the internet. Okay, you don't get to say I got this course from internet, but it was simple code and I included it in my homework. Doesn't matter. That's called cheating, and if you cheat, we will punish you. Okay, I don't know. I don't want to say how we are punishing the cheaters, but we will punish you for that. Okay, so those are the rules. And as I said before, even a single line of code coming from somewhere doesn't matter. I believe those people. They say that I spent at least 12 hours to do this homework, didn't sleep 2 nights. Only single line comes from this friend, and am I going to get this treatment? And the answer is yes. Okay, doesn't matter 1 line, 2 lines, or the whole homework. Cheating is cheating. Okay, as I said before, this is a very crowded class, more than 100 people, more than 120 people. We cannot make this decision of, okay, this student is a good one, let's skip this penalty for this student. It's just 1 line of code and etc. No, we don't have those kind of rules. If it is cheating, it is cheating, and the rules are fixed. Okay, so these are the things that we are going to cover. Okay, since you don't know the object-oriented programming, you will not know what these are yet, but just to give you an idea, we will make an introduction to C++ programming, classes and the objects at the beginning. This will come from the C, okay, control structures, functions, and arrays. Okay, so these will be something similar, familiar to you. So that will be very quick. In 1 or 2 lectures, I will finish them. Pointers and strings, again, you already know them, most of them. There is a new string class in C++. We will talk about it, but basically it will stay the same. Then the real stuff starts from this on, classes and data abstraction. Classes are the main building blocks of the object-oriented programming, not C++, but all the object-oriented programming languages. Okay, we will talk about them a lot. And when I say classes, actually, classes are just extension of structures. You remember the structures that you learned from C course? Okay, they are very similar to structures. Syntax-wise, there is almost nothing new. Okay, but idea-wise, they are very different from what you know in terms of programming technique. You have been doing structured programming, okay? Writing functions, inside the functions, writing your loops without the go-to statements, and writing lots of meaningful functions and calling them all over, okay? That's what you have been doing. We are going to do structured programming in object-oriented programming, but there are other stuff too. And classes are the main tools that will do the object-oriented programming. And abstraction, you are going to hear this keyword a lot in this object-oriented programming course. Also, in your next semester's course, data structures. Also in other semesters, because abstraction is something all the scientists use, all the engineers use, and computer science people, they love abstraction a lot. Operator overloading is something specific to C++. We will talk about it. Then another important concept in object-oriented programming is inheritance. Inheritance is, some people say that object-oriented programming is good for code reuse. Okay? What is code reuse? Using the code that somebody or yourself, okay, had written before. That code is written before, okay? And why not using it over and over again? Because if the code is healthy, it is running fine, it is debugged, everybody likes it, it is easy to use, so I'm going to use it. If you use such code, okay, very usable, user-friendly, programmer-friendly code, your code will be a good code, okay? That's why we like reusing the previously written code. And you have been doing it, okay? You did not write the square root function, right? Somebody wrote that square root function and you used it. And in fact, most of you don't know how the square root function works, right? We have been using it without any thinking about how that thing works. That's called functional abstraction. I abstracted that function in my head. I don't care how it works, but I'm just going to call it, okay? Inheritance is another example of code reuse. It is not like function call, but you say that there was a code before and it used to work such and such. I am going to extend a little bit. I am going to change it a little bit and it's going to make a new building structure for me. But the old code will work as before. It is not going to change. My new code will be a little bit extension of it. That's called inheritance. Okay, and the virtual functions and polymorphism will be built on top of inheritance. Then templates, exception handling, standard. Okay, this STL, I'm going to skip these two. They are kind of difficult to talk about right now, but again, features of C++. The standard template library is the standard library of the C++ language. Okay, it includes many useful classes, functions, and other data structures. And we will be using the standard template library. Sometimes it's called STL. Okay, we will cover it in a few lectures, but throughout the semester we will be using lots of classes from standard template library, and we will cover it. And at the end of the semester, maybe in the last 2 weeks, I will make an introduction to Java and I will compare it with C++. By this time, you will know all the basics of object-oriented programming through C++. And of course, I will not I will spend maybe 80% of my time, maybe 60% of my time talking about the object-oriented programming rules while I am talking about this stuff about C++. So object-oriented philosophy first, then how you do that thing in C++ next. Okay, when it comes to Java, okay, at the end of the semester you already know about object-oriented programming, so I will skip that part and I will only tell you how you do that object-oriented technique in Java. That's why this will be very, very fast. Very, very fast doesn't mean that Java is easy. Well, okay, it takes lots of time to master the Java programming language, but I don't have to spend more than 2 weeks because the rest of them will belong to you, and I will compare it with C++. So that will be whole semester. Any questions? Yes.
Is there a book for Java?
Is there what?
Is there a book for learning Java?
Well, when we start talking about Java, I will talk about a few books, but mostly no. I will talk about it when we start talking about Java. Okay, but I will not ask you to buy a Java book. Good. Okay, let's move on then, and let's talk about why we are studying C++. The first reason might be because C and C++ are very popular languages. Okay, this is the graph of the popularity of the programming languages in the last 20 years, and Python is blue, C is black, and kind of green is Java, then C++ is here, C#, Visual Basic, and etc. As you see, in 2002, Java was very popular at the top. How did they calculate these numbers? Well, I don't know exactly, but usually I think they are taking a survey. They ask people, professional programmers, professional software engineers, what kind of programming language they use, and I think they scan the job postings, okay, on the internet, what kind of programming languages are used most, and these are the numbers. So 25% of the people, they said that they are using Java in 2002. This is C and this is C++. And Python is this blue line. So it was here, and where is it? Yeah. So in 2002, Python was like there, right? Okay. So as you see, Java, C, and C++ are very popular. The rule did not change much. What is this language? PHP. Yeah, people have been using it a lot. They are still using it. It's getting popular and popular and popular. Then it kind of winds down and it goes away maybe. But nowadays, when you look at the picture, see this one, C and Java. It was very popular in 2010s. Java is still very popular today. Okay, but nowadays, I think it happened last year. Python is the most popular language nowadays. Then C, then Java, then C++. C++ is kind of gaining again, but it is not going anywhere. The thing I am trying to tell you is that C and C++ and Java, okay, they were popular 20 years ago. They are popular right now, and they will be popular in the foreseeable future. I'm not saying 20 years, but it will be popular. That's why, I mean, when we are looking at jobs and what kind of programming language do you need to know, and these are the programming languages. I don't know if Java is going to continue this trend all the time. It's going to get popular and popular and popular. There is a reason why each one is getting popular. For example, you never give up C because there are some properties of C Nobody can do it as better as good as C. For example, C say that I am fast. It's really fast. It doesn't use much memory. Okay, it is very efficient, and it is portable, and you can do low-level programming with C programming language. That kind of stuff. Okay, C++ says that I am object-oriented programming language. Yeah, kind of. Some people say that no, C++, nor Java, nor C Sharp, they are not object-oriented programming languages, or they are not proper object-oriented programming languages. But C++ says I am both object-oriented programming language. I can do low-level stuff. I am reasonably fast and efficient, and I am almost compatible with C programming language. These are some unique properties. And Java says that I am a much better object-oriented programming language than C++. Okay, and I am not as fast as those, but I have lots of libraries. For the enterprise software, I am very easy to use, because if you are doing to, I think it's going back. Okay, I will keep it. No, just keep it there. Okay, I will keep it next class, next lecture. I will give it to you again. So those kind of things. Python doesn't say that I am fast. Python doesn't say that I am object-oriented programming language. Python doesn't say that I am efficient. It only says that I am easy to use. Okay, you know the popularity of the artificial intelligence, machine learning, deep learning, right? Everybody started using these techniques, and many people try to use artificial intelligence libraries. They are not very good programmers. They are not very good software engineers. So how do you start programming in a very short amount of time? Use a programming language like Python. It is very easy to use, very easy to learn. In fact, we don't teach Python in this department. I think you learned it a little bit in 101, right? Did you? No? Okay. Doesn't matter, because it will take you, after taking these two courses, it's going to take you maybe a week or so to learn Python. We don't teach Python in this department, but I think last year 80% of the fourth year students, they use Python to do their graduation projects. Because as I said, the libraries are there. It is very easy to use, very popular. I am not saying that it's a bad language, but it is different from C, C++, and really Java. Yes?
Why C sharp is not on this list? Is it popular?
C sharp is it is going away, right? Is that? Yeah, this one is C sharp, right? I think this one is C sharp. Yeah, it was popular for a while, especially around there. So you know, C sharp is kind of a Microsoft version of C++. So Microsoft was pushing it. Later they gave up, or they weren't very successful. Or there was some stupid Apple language. Did it go away? I don't know where it is. Okay, so there are some languages they come and go, and there are some languages they will stay. Okay, and C++, C, and Java are these three languages.
Is with Apple languages Swift or Objective-C?
Yeah, both of them are stupid, including Apple. Yeah. So this is one of the reasons. The other one is, if you are a environment conscious people, okay, if you are such a person, I got this from this publication, Energy Efficiency Across Programming Languages. Okay, I am not sure if this publication is a very well performed, well done publication, but the numbers are kind of make sense. If I write the same program in C, C++, Ada, Java, Pascal, Lisp, whatever, okay, let's see how much energy it consumes for the same program. Okay, C is the most efficient. Okay, if you are trying to save energy, okay, if you like to be a green person, be respectful about our environment, then C is the way to go. Okay, it doesn't use Well, you have to use some energy to do some computation, right? C is, maybe it is difficult to write, more difficult to write programs in C, but when you are done, when you write proper C code, it will be very fast. You are going to spend 1 unit of energy to do the task. When it comes to Python, it's going to be 75 times more energy. Okay. Other good languages, C++ or Java or Lisp. By the way, Lisp is it was invented in 1950s, and it is the second after Fortran. It is the second high-level language invented. Fortran might be the most stupid language ever invented. It was the first. Lisp might be the most sophisticated language ever. Okay. It is both functional, it can be object-oriented. And unfortunately, we don't teach Lisp much in this department, other than the programming languages course that you will be taking next year. Okay. Lots of variations of Lisp. So Lisp, although it is interpreted, it is energy efficient. In terms of time, again, C is very good. You won't beat C in terms of time. Python, as you might have guessed, it will be very, very slow. You might say that, well, doesn't matter if it is slow. My machines are very, very fast nowadays. I have 8 cores on this cell phone computer, right? I mean, why worry about speed or efficiency and that kind of stuff? But I mean, if you write code and 2 billion people are going to use that code, okay, if you add up all these numbers, energy and time, that will make lots of difference in the cumulative sense. That's why we should be careful about that. And memory usage, again, C is at the top, Pascal is there, C++ is there. Where is Java? Java is not that good in terms of memory usage because Java is kind of an interpreted language. There is a Java compiler and Java interpreter. Okay. Again, where is Python? Python is here. Okay. So it is not like 75 times more memory, but in terms of time and energy, these are the rules. Okay, this is the maybe second reason why we are studying this. The third reason is your department had chosen this way. Okay, in Turkey, I think there are 2 or 3 kind of schools of ways of teaching programming. One group of department, they start with C and C++, like we do, usually the state universities, and the others are they start with Java, then they try to teach C and C++ later during the data structures course and etc. The third kind, they start with Python and they never teach C and C++. That's the third kind. Usually some non-state universities, they do that. We are the first group. We say that C and C++ and Java are the foundations of nowadays computer programming, and they are the way to go. Once you learn these languages, it is easy to learn the others. Once you learn C++, it is very easy to learn Java, okay? Especially in terms of object-oriented techniques. If you do it the other way, learn Java or Python first and try to learn these languages, it's not going to be very intuitive for you. There will be some things that doesn't make sense much, okay? You will be asking the same question, why are we doing this and why are we doing this? But if you start from C, when you go to Java, you will understand everything, why we are doing that and that and that. Because C and C++, they came first, okay? When they designed C++, when they added a new feature, they added that feature because that feature is missing in C. Or C didn't do that thing very well. So they change it. When when Java came, okay, they didn't like some features of C++, so they changed those features, okay. And we are going to follow the same historic development of those languages. Well, our path of working programming languages will be long, and it will be a little bit difficult, but it's going to be worth it, okay. You are not programmers. You are not going to be programmers. You are not going to be like a mechanical engineer doing some AutoCAD work, okay? They are using computers. So you are going to be computer engineers. You are going to be computer scientists, okay? You need to learn all the basics of the computer science, and including how the machine works physically, hardware-wise and software-wise. Okay, so that will be why we are studying C++. And which version of the C++? C++ has a number of major versions. C++ 98 was the most popular maybe 5 years ago. Nowadays, people started using C++ 11. So we are using C++ 11 in this course. That doesn't mean that C++ 11 is the latest accepted standard version. There is C++ 14 and C++ 17 and C++ 21, and I think they are working on C++ 24 now. Okay, they are going to make it available. So why not study C++ 17 or 20 in this course? Because they are about C++, not about object-oriented programming. Okay, in terms of object-oriented programming, even C++ 98 is good for us. But since this is more popular nowadays, the book says that I am going to do C++ 11. We are going to do C++ 11. And whenever I talk about a feature that doesn't exist in C++ 98, but in C++ 11, I will tell you so, because sometimes you need to code in C++ 98, not in C++ 11. And in fact, our compiler, G++ compiler, by default, it compiles C++ 98, not C++ 11. You need to make a switch. You need to say that, okay, this code is C++ 11. Okay? So don't think that this course or this book is an old book, or this course is an old course. As I said, this course is not C++ programming. It is object-oriented programming. We just use C++ as our solid, concrete example of object-oriented ideas. That's why I don't need to talk about the details of the new C++ versions. Okay, so that's the basic introduction to our course. I will take like 10 minutes of break. After the break, I will come and I will start from here. And if you have any questions, and I will get your questions after the break. 10 minutes. Herkesin kaydı olsaydı şey yapacaktım ben, e-mail yollayacaktım. İşte onu bekliyorum dedim. Ama ben yapar onları bir şekilde.
Yok, şeyden sonra abi.
Siz aldınız mı?
Şimdi break'ten sonra.
Break.
Mola aklıma geldi break.
Hocalar geliyor.
Hocam. Abi reis. Bu da mafya Altı ay kesmedim dedin ya. O halde çeksene görsem var mı? Ama var ya çok böyle anladı da güzel geliyor. Bu var ya bir taneye girsem hafızayım abi ya. Hadi çıkar. Bura boş abi. Yan yok.
Benim seçme dersine çıkar.
Sen kimsin? Ya hangi ders? Ben ne bileyim ya. Ben bir sürü seçme ders çıkardım. Geçen dönemki notların kötüdür.
Seçme dersi notu mu?
Yok, tüm derslerim nokta.
Fazla grevden mi çıkıyorsun?
Evet, 30 krediden fazla kimseye vermedim. Sadece geriden gelip de eksik dersleri tamamlamayan çalışanlara verdim ama geçen dönem verdiğim derslerden de kalmış. Bu dönem niye fazla vereyim ki? Ben demek kabul. O yüzdendir. Senin hakkında konuşmuyorum ama şey yaptığım kural oydu. Geçen dönemki notlarına baktım. Eğer verdiğin derslerden kalmışsa fazla ders vermedim.
Hocam aynı dersin yoklamasını atamadım da.
Tamam bekle, ikinci ders vereceğim. Şurada.
Hocam seçmeli derste Rusça mesela online sadece Rusça alabiliyorum. Zaten online olacak ama 60 kişi kontenjanı var. Bu yüzden Rusça 2 alıyorum. Rusça 1'in kontenjanı sınırsız olursa olmaz mı? Zaten online olacak sınıf. Öyle ya.
Online ders nasıl oluyormuş Rusça anlamıyorum ki ben ya. Rusya'da mı hocam?
Bilmiyorum. Rusça 1 var, Rusça 2 var. 60 kişi kontenjanı olduğu için Rusça 2 alacağım.
Hocaya sorun.
Hocam ben bir şey
Efendim? Evet buyurun. Teşekkürler. Siz de nasılsınız? Ha. Ya ben onu okudum. Kararımı da verdim esasında. Bugün hemen gidiyorum. Çok teşekkür ederim. 23.59 değil de 02.59 olabilir mi? Yo ben bu gece gelirim de yani gece 12'de hayat yeni başlıyor akademisyenin yani. Yo ben bugün girerim yani gece 12'den yani 1'e doğru girmiş olurum onu söylüyorum. Ya tamam. Tamam. Ben öyleyse sıkıştıracağız bir şekilde. Tamam. Teşekkürler.
Hocam devam zorunlu olanlar yoklama kağıdında bir Excel'de isimleri var da devam zorunlu olanlar orayı mı imzalayacak? Çok iyi anlamadım da.
Herkes yoklama kağıdına imza atacak. Dönem sonunda sayacağız oradan. Devam zorunlu olan da olmayan da.
Yok hocam kağıtta bir Excel tablosu vardı da.
O yanlış o dediğim ya. Herkes izini yazsın dedim oraya. O çıkmamış. İkilerin karışmanı henüz şey yapma sen yüksek zam.
Arkadaşın ismini karşısına almadım. Normal istedim.
Perdeleri de camları açın olur mu? Camları. Perdeleri de camları. Hava gelsin ama güneş gelmesin.
Okay, so let's start the real lecture. I think I scared you enough. Where is my? Oh, somebody said that the Teams page is not public. I don't know how to make it public, but let's try to figure that out. When I say this is okay, how should I make this available to you? I don't know. Okay. I made a team. Okay. Take a note. This is the make this larger. How do I make this larger again? Shift like this. And just a minute. Yeah. So this is the code. Okay. So add this. I think I will make this link available. I will make this link available in our departmental page later, but if you like to add it now. So let's go back and let's start. Okay, so chapter 1 again directly from the book. The book slides are available in the at the Teams page. Okay. So we are going to learn about object-oriented programming, origins of it. Object-oriented programming was invented in 1960s. Okay. The first examples of object-oriented programming, they were very different from our C language or C++ language. Later, when they realized that object-oriented programming is way to go in terms of code reusability and code maintenance and design principles and etc., they try to integrate these kind of principles in the mainstream programming languages like C. So they came up with this idea of C++ in 1988 maybe. Okay, AT&T Labs, Björn Strostrup. This lab, AT&T, okay, directly from the Thomas Edison's lab. They have invented lots of stuff. They invented Unix, okay. They invented C programming language and C++ programming language. Maybe the laser they have invented. There are many things they have invented, and one of them is the C++. They say that, okay, if we add these features to C, then it becomes an object-oriented programming language. And the original designer, original inventor of the object-oriented programming, he doesn't think that C++ or Java, they are pure object-oriented programming languages. But C++ never says that it is perfect object-oriented programming language. It says that I am like C, but different from C. I can enforce object-oriented programming principles. So it is easier to code or design systems with this programming language. Okay, so we are going to look at this kind of history, and we are going to look at our first program and our variables, expressions, etc. Console input output, that is printf and scanf, programming style and libraries and namespaces, etc. Okay. Low level programming language. What is the lowest level programming language? Assembly, right? Machine code is not a programming language, but machine code is directly what the machine executes. Assembly is very similar to machine code. Instead of remembering the opcodes, the binary numbers for the instructions, we just give them names. Then we have the high-level languages, C and C++, A, etc. The difference between two is high-level programming languages are closer to this is what they say. Are closer to human thinking. Okay. We think in terms of variables, we think in terms of expressions, we think in terms of comparison, etc. These programming languages provide these kind of mechanisms for us. So it is for us human beings, to write code that the computer can understand. Okay, it is very difficult to translate a Turkish sentence or English sentence to an instruction that the computer understands, because human languages are very difficult to interpret and understand for the computers. Even in fact, human languages are very difficult to understand for the humans too. Just translate this to Turkish. This is an example that I'm going to teach this afternoon in the natural language programming, natural language processing course. I made her duck. Translate this to Turkish. Raise your hand. Onu ördek yaptım. Ördek yaptım. What else? Yes. Onun ördeğini yaptım. What else?
Onu vakvaklattım.
Onu vakvaklattım. What else? Ona ördek yaptım. So how many meanings do we have from a single sentence? Is this a problem with English or Turkish? Well, this is what natural language is, right? You write a simple sentence, it means many things. Computer languages cannot be like this, okay? If you write a statement like this for a computer and compile, the computer will tell you that this is an ambiguous statement. I cannot compile it, okay? I cannot compile it. For example, if I have a function that takes, for example, a character, and I am sending, okay, let's say I have another function, the same name, it takes a short integer, and if I am sending a double to this function, okay, the compiler would not know if I would convert this double to a character or short, okay? It's an ambiguous statement, so it says that I cannot compile this. But in real life, we learned how to live with these kind of statements. Even doesn't matter it is Turkish or English. That's what makes human languages more powerful. We say very little. Other people, most of the time, they understand what we mean, right? But in programming languages, that doesn't happen. We cannot say this little. We have to write very lengthy programs, and the compiler, doesn't matter what compiler it is, it has to understand exactly the same thing. There is no ambiguity, okay? There is no different senses for the same language, same sentence, okay? Human beings, they work like this, okay? They like ambiguity in their sentences because this is more powerful. You don't have to talk much. You just say a few things and people understand it from the context maybe, okay? And why not use the same idea, very little saying, and the compiler understands it? So they invented this high-level languages, but still, whatever you are saying cannot be ambiguous. It has to mean exactly the same thing, only one thing, okay? So high-level languages, they say that I am similar to human languages, at least in terms of how they look, but again, I am close to the machine because I only mean one thing, okay? And object-oriented programming says that I can do this better without being ambiguous, okay? Without behaving like a human language. If you use my principles, object-oriented programming principles, then your programs will be more understandable by the humans. They will be easier to design, they will be easier to maintain, and they will be easier to reuse, okay? That's what the object-oriented programming says, okay? It doesn't say that I am going to teach you something. Using these things, you are going to do stuff that no other programming language can achieve. No, we don't say that. Whatever you can do with C++, you can do the same thing in C too. Well, in fact, all of whatever we do, they are all translated to assembly and machine code, right? So you don't talk about this is possible in C but not possible in C++, etc. Whatever you can do in C++, I can do the same thing in C or assembly in machine code. The thing is that for us human beings, the experience shows that working in an object-oriented programming language is better in terms of development time, in terms of maintenance, in terms of extension, in terms of many other documentation, etc. So that's what we are going to do. So don't tell me anything about, well, I can do the same thing in C, this and this. Yeah, that's true. We are not talking about neat things that you cannot do in C. We are talking about the way that you should write your programs or the way that you should design your programs. That's called object-oriented programming. Okay. So we are going to come back to this idea a lot, and as I said, most of the time I will spend my time for telling you what object-oriented programming is. Then I am going to give you examples in C++ how to do that in an object-oriented programming language. In C++ terminology, we have, of course, functions and programs, like in C. We can do basic input-output, like we did in C with printf and scanf. This time we are going to use some other stuff. This is our first program. As always, our first programs are always programs that doesn't make much sense. It is a simple program, but this is good for showing you what we are doing with C++. Okay, familiar stuff, include. Okay, we know the include. We know the include. Okay, it's a preprocessor statement, preprocessor directive. Okay, and it includes a header file. We did not see this header file before. Okay, stdio maybe is something similar to this one. So it is about input-output header file, IO stream, input-output stream. We are going to talk about streams later. So the line number 1, it includes a header file. Okay, and the meaning of include is exactly the same as before. Okay, line number 2 is something that we did not use before. It's a namespace statement, and I am going to skip it for now. Just ignore it. We will talk about it. In fact, there is a complete chapter about namespaces. Namespaces, they are not necessarily part of object-oriented paradigm, object-oriented programming paradigm, but usually we use them with the object-oriented programming languages. Our main function. The rule is every C program is going to work, okay, if it's going to run, it should have a main function, right? The same rule applies for C++ too. It should have exactly one main function if it's going to be an executable program. It returns an integer and its name is main. Okay, it starts from here and ends there. As you see, our indentation rules are the same as C. It is exactly the same as C. We start our function with a curly bracket and with a curly bracket, and we indent all the statements in a function like that. And sure.
Why is the main function is called as an int? Is it for it's come from the integer, right? But it's kind of weird.
Well, this main function returns an integer. This is the return type. This is exactly the same as C. In C, we do exactly the same thing.
Yeah.
So there is nothing new in this. Okay, this comes from C++. This part is kind of C++, but yeah, it's just a header file. Line 3, 4, and 5, They are exactly as in C, no difference. This when you say int number of languages, you are declaring an integer. Okay, and line 6 and 7 is something different. Okay, we did not see this in C because they don't exist in C. Well, in C we have operators, right? 2 plus 5. Plus is an operator. It takes two parameters, okay, left and right. It adds them and it returns a new integer, right? And this is an assignment operator. Its task is it takes two parameters again, left hand side and right hand side. Whatever I have on the right hand side, I assign it to the left hand side. That's why it's called the assignment operator. It looks like I have an operator here. Okay, this one is called stream insertion operator. It's an operator, okay? It takes two things. The thing on the right is a string that you are going to print on the screen, and this is character out. This is a variable. This variable is defined inside this header, okay? It's a global variable. Okay, it's a global variable. This global variable is defined inside this IO stream header, and it will.
Hocam şu arkadaşım biraz kalp rahatsızlığı oldu, ambulans çağırdık. Arkadaş hani yok yazılmasın diye beni gönderdi. İsmini söyleyeyim mi size?
Tamam, git onunla ilgilen ya, hallederiz.
Yok şey güvenlik değil de hocana haber ver dedi.
Tamam, sağ ol. Geldiler mi?
Evet hocam.
Bizim sınıftan mıydı giden? Arkadaş bizdeydi değil mi? Ders arasında mı olmuş?
Yok, arada oldu.
Burada mı kötüleşti dışarıda?
Aynen, tuvaletinden de gördüm de. Bayılıyor gibiydi. İlgileniyor arkadaş.
Okay, so this is an insertion operator, and its task is to print something on the screen. Okay, so when this operator works, it takes the string and prints it on the. It takes the string, it prints it on the screen. That's what it does. Okay, and you might say that what is this? I mean, that's the task of it. How about this one? Well, it is very similar to this actually, right? So this one will take, this plus will take 2 and 5. It will produce an integer, and this one will take that integer and it will produce another integer, right? That's kind of it, but it is similar, maybe it is more similar to this. A gets the value of B, it gets the value of 2, right? So I first execute this one. I assign the value of 2 to B, and the result of this operation is a 2, and I assign that value to A. Okay, so these are cascaded operator executions, and we have been doing this in our C programming experience, right? And I'm doing the same thing here. This one takes this parameter and this parameter. It will print hello reader on the screen, but this one has to return something. It's an operator. What does it return? It returns exactly the same thing as the cout. Since this line has returned a cout for me, so it becomes cout stream insertion. Welcome to C++. So it will print another string to the screen. Welcome to C++. So in together, line 6 and 7, both of them, okay, both of them, they will do something like this. Let's write this in C. Printf. Okay, tell me what should I do? Okay, I should have a format string, right? What should I write in here? What? What should I write in this there? I can write hello reader, but that wouldn't be exactly the same thing. I think I should write %s, okay, and %s, and then comma, and a string hello reader \n, comma, welcome to C++ \n. That would be exactly the same thing. Okay? Yeah.
Ya bu stream C'deki buffer'a tekabül ediyor mu?
Are you talking in Turkish?
Stream is kind of is similar to buffer in C.
Well, I am saying that these two lines, they correspond to this printf statement.
No, I'm talking about stream. It's kind of similar to buffer.
Oh, you are talking about the streams. Well, I don't. Let's ask me that question maybe 6 weeks later. Okay, because we are going to talk about streams. Yes, I mean, in any computer environment, software environment, if you are sending some data to some other place, in this case we are sending data to the screen, buffering always occurs. Okay, yeah. The answer is yeah, but there are lots of different types of buffers, and what kind of buffer we are going to see. Okay. And then we ask this question: how many programming languages have you used? Cout statement. Okay. Again, don't make this stream insertion operator confuse you. It's a simple operator like the plus operator or minus operator or the assignment operator. It has a defined task. It takes two parameters and it executes something and it returns something, right? That's what it do. And then a new thing here, cin, and this is called stream extraction operator here. This one is a stream extraction operator. The stream extraction operator, again, it takes two parameters. One of them is a global variable, again, cn, character in, okay. The other one is the variable that we are going to modify. It reads an integer from the keyboard and it puts that integer inside this variable. So the corresponding C statement for this one would be scanf and then what? Scanf %d and what? Ampersand, don't forget this. You know what happens when you forget that one, right? Ampersand and the number of languages. This is the corresponding C statement. Okay? And then the rest is kind of understandable. There is an if statement here. If the number of languages is less than 1, then this book is not good for you. You should know a programming language before, like C. Otherwise, the book is good for you. And at the end, I return a 0, telling the operating system that my program executed nicely without any problems, and I am returning a 0. Yes?
Which one is safer, cin or scanf?
Well, in C++, we don't use printf or scanf. We use cout and cin. Okay? So it's not a question of which one is safer. Okay? It's a should we use printf and scanf? By the way, I mean, what do you mean by safe?
I mean,
In terms of data security, system security, etc.
yeah.
None of them are safe. No. C and C++, okay, they are known for they are not very good at providing system safety. there are lots of problems, especially with the library routines. Okay, their handling of the stack, their handling of the buffers, they are vulnerable to some attacks. Okay, but we don't talk about those. By the way, I mean, in this course we use CNC out a lot because we need to print something to the screen to see what has happened. In real life, you don't use CNC out much because in real life, your outputs will not be okay. This is what we are going to do. Let me open up a kind of a Linux emulation window for me. Okay. Yeah. I think I have this program. Yes, it is here. Let me remove all the .o. Yeah, okay. So this is my program 0101. I got this directly from the book. 01 means chapter number 1, and other one 01 means the first program in chapter 1, number 1. And if I show you the program, it is this one. Can you see it? How can I make this? Is it the color or is it something else? Maybe here. Colors. Maybe the background should be white and the foreground should be black. Is it better? Okay, so this is the program, exactly the same program. Okay, and okay, this is exactly the same program. Usually we don't run our programs in an environment like this, right? In a Windows operating system like Windows or the Mac OS 10, it is all Windows. You click stuff, right? You minimize stuff, you maximize stuff. To run something, you double click on it and etc. That kind of stuff. So to print something on a window like that, you don't use CNC out, etc. The input-output mechanisms are very, very different in our everyday life. So C in and C out are not used much. For the input-output, there are other libraries available for us to use. Okay. So the answer to your question is C and C++ are not very good at providing safe, system safe, data safe ways of inputting and outputting. And many things, the stack overflow is the biggest problem of C and C++ language, also Java too. And when you can control stack, what is stack overflow? You use the stack. When do we use stack? Do you guys remember from your 102? When we use the stack automatically whenever we do what? Whenever we make a function call, right? Whenever we make a function call, all the parameters and the return address is stored on the stack. If you keep calling the same function or different functions over and over again, our stack is not large enough. It overflows. As an hacker, if I use this feature in a careful way, I can write malicious code in the places of the memory that I am not supposed to be seeing, right? And C and C++ is very vulnerable for these kind of hacking attempts. And again, this C and C out, when you say print the string, if that string doesn't have an end of line or the \0 character at the end of it, it's going to cause some problems. Okay, so these are not safe. But this course is not about data safety or system safety. Okay, we are talking about object-oriented programming. Okay, to make these kind of stuff safer, there are ways of dealing with it, and C and C++ can be used in that case too. Okay, so this is the program. When you run this program, compile and run it, you are going to get something like this. Hello reader, welcome to C++. How many programming languages have you used? It says 0, and it says read the preface, and this is not a good book for you. If you have used one programming languages before, then this is okay. And this is how we compile stuff. We say G++ minus C hello CPP. Okay, let me compile it. Where is my, here it is. Okay, G++ minus C is for compiling. Compile this for me. Okay, it compiles, and it came back saying nothing. That means that I am successful, no problems. Let's see what it did. It produced this .o file, object file. It's a linkable but not executable file. Let's link it. We are going to link it against the standard library so that I can make a runnable code. Okay, and how I link it? G++ minus O. I am linking it, and my program will be hello and 01.o, right? I linked it. Now hello is there. It is runnable. Let's run this. Let's run this. Hello. Okay, hello reader, welcome to C++. How many programming languages have you used? I've used 34, and enjoy the book says. Okay, this is how you compile and run. Basically, I mean, this is our most basic terminal interface, and our computers 30 years ago, 40 years ago, it used to be like this, a black screen and 80 columns of screen space, 80 by 40 maybe. Okay, you just type your stuff here, you compile it, you get your results, and you run them back. That's how it used to be. That's why it was very simple. Very simple to write, very simple to compile, and very simple to see the results. That's why we like this interface. If you try to do other stuff like the windowing and development and environment and etc., well, they are nicer to do stuff, but they are difficult to understand. So at the beginning we start this environment for our C and C++ courses. Later I am going to teach you how to do graphical user interface programming in Java, and you are going to see that it is not that difficult. It is detailed, but it is not that difficult. Okay, good. So I think I have a few, some compiler switches. I have seen this. What is this? This is compile switch. This is link switch, right? Does anybody know what this is? Minus G. Minus G. Minus G means include debugging information in my produce code so that I can debug it using a debugger. What is minus O? Okay, there is big O. Okay, what is minus big O3? Big O3 means that optimize my code as much as possible. Okay, when the compiler optimizes your code, okay, it may say, for example, if you have some code for I is 0, I less than 100 plus I, let's say I have some 0, some guess the value of I, some gets incremented by I. Okay, our compilers are smart enough to see that in order to run this code, you don't have to run it, right? I know the result of this 3 lines of code. The 3 lines of code is what is the summation of all integers from 0 to 100? It is 6,000 something. What? Do you guys remember? It is n time, okay, times, right? This, right? N times n plus 1 over 2. You remember this from your primary school, right? Okay, what is this? I think this is like 50 times, so 5, something like this, right? 5,000 or something. The compiler is smart enough to see that if I run this, sum will be 5,000 something, okay? It executes it, and it doesn't produce any code to run this. It directly assigns this value to sum. So your produce code in your machine code doesn't have any loop statements, okay? It is smart enough to do that, okay, when you do this kind of optimization. But if you don't do optimization, it will produce code to do this, okay?
Each switch optimizes.
What?
Each switch optimizes this, right?
That's what I said, minus O3.
Minus.
Yeah. And there are others like minus capital S, minus E. What is minus capital S? Does anybody know? Let's try it. Let's try it. So where do I get all this stuff? You go to manual page of G++. Okay, it says that G++ or GCC is the same thing. Okay, is a compiler, and these are the options. Minus C, you remember it, right? Minus S, minus E, my standards, minus G, and there are many options, and let me show you some of the option switches. Okay, these are C language switches. For example, when you say I need NCC, very old C standard, or the other standards, STD equals C++ 11 or 17 or 24, etc. Okay, C++ language options, many of them are there. Most of them I don't know what they are. You need to read the documentation. Okay, these are Objective-C stuff. Warning options, don't give me a warning for that kind of stuff. Okay, debugging options, C minus G, or include more debugging options in there. Optimization options, okay. Let's see some of them. If you can we, do I know anything that I know, or I can tell you that this is go branch target load optimized too. Some of them are very specific. You need to know the processor structure to understand what they mean. Well, it looks like loop block, loop nest optimize. Sometimes it is when you do a loop, okay, let's say you have a loop runs from 1 to 5. Sometimes it is much faster to unroll the loop and write 5 statements one after the other, okay? If you are running the loop 5 times, don't run the loop 5 times. Unwind the loop and write 5 statements one after the other. This is faster than running the loop. Compiler can do that kind of stuff for you if you do that unwinding. So as you see, there are many optimization options, many other options, assembler options, linker options, and this goes on and on, right? It looks like there is no end, and there will be other kind of specific options. Now these are the explanations. So if you need to know what kind of options I have, you will read that documentation. Let me use this one of these options, minus S. Okay, it did something. Let's see what it produced. It produced a file .s. Okay, its size is 3 kilobytes. Let's see what we have in that file. What do you see? These are Intel architecture 64 statements. These are assembly instructions, okay? So instead of producing the machine code object file, it says that I compiled your program into a assemblable, okay, program. Okay, you can feed this program to an assembler and you can produce your code. So I can know what kind of code I am producing. I think these calls, see there is a call and call and call, okay? These calls are for, okay, remember those C in and C out statements? Those are function calls actually, okay? These calls are for that. Usually, if you put the program next to this one, you will understand which one is producing what. Intel architecture 64, okay, assembly instructions are a little bit more complicated. There are simpler instructions. There are simpler processors that you can understand even better. For that, I use this nice website called Compiler Explorer. With this Compiler Explorer, I can choose my compiler and the target processor. Okay, this one again uses Intel architecture, and this is my, for example, this is my simple program. It just does a square. It just takes an integer and it returns the square of it. And here you see integer multiplication. It multiplies the register by itself. Okay. If I make a, for example, let me make a change. Let me do this. Where is my, 9. Okay. So see this one, line number 5 corresponds to line number 3 over there. So if you need to know what kind of assembly I am producing for my C or C++ program, you use these kind of things. I can talk about this kind of stuff when you do C and C++. It is impossible to talk about this if you are writing your code in Python, okay? Because in Python, everything is interpreted. You don't know what's going to happen with your code. It will be translated again. There will be many processes going on. It is very difficult to think in terms of what is the processor doing. But in C and C++, it is very easy to guess what the processor is doing. That's why it is much easier to write efficient code. When you make a decision, you know what the process is going to, how the process is going to behave. Okay? That's why we have that many compiler options. That's why you can easily see your corresponding assembly of your program. And if you don't like your produced assembly code, this does S code, you can modify it yourself. Produce your assembly code, add your additions in there, make your modifications on the assembly code, and assemble your code, and you will get the help of C to compile your program, and you make it more efficient by writing more assembly to it, right? That's why we like C and C++. They can behave in a very low level. Yet C++ says that I am an object-oriented programming. I can behave in a very high level too. Okay. So I think I am way out of my time. I will stop at this point. Tomorrow morning we will continue from this point on. See you tomorrow.
Gezlerde ne yapacağız?
Dönem başında